Hi, I'm Nathan Shively-Sanders, and let's finish talking about assignability in TypeScript. So in the previous two videos, I talked about the background of what is assignability, and then how structural type checking works in a very simplified, abstract way. This time, let's talk about how TypeScript actually works. It is, as you can imagine, much more complicated than the simplified example that I showed earlier. The example I showed earlier had two phases. It had primitives, things like number and string, and it had object types, which are like functions and objects. And that was it. TypeScript has 6 phases, and I'll explain these later, but they are pre-checks sometimes, primitive types, ad hoc checks, recursion checks, structured types, and object types. And these phases are laid out recursively, so one phase will run, and if it comes up with an answer, it will return, otherwise it will recur into the next phase. And then there's a recursion point sort of right about here where there may be a loop. And you may loop deeply into some recursive type. So the first step is pre-checks. There's a lot of wrappers inside the compiler code that wrap around check type related to. Check type related to is the main assignability function, but there's a bunch of other wrappers. For example, elaborate error does some post-processing to provide good errors. It tries to like minimize the number of extra lines that you have and so on. But the very first thing it does before calling check type related to is making sure you actually passed a node in to issue the error on. And if you didn't, then it just fast exits. So that's a really simple check, but there's other ones that do some sort of pre-processing or some extra checks beforehand. So be aware if you're looking at the compiler code, lots of things call into check type related to. The first actual set of checks is simple type related to. So first off, you use triple equal. Same as before, you just check for identity. That's the sort of always the first fast path. And then you use flags after that to quickly check primitives and unit types. So primitives are things like string, number, boolean. And unit types are things like string literals, number literals, boolean literals. But also like enums and symbols. So for example here, if you have const source equals and then the string literal, that gives the source it's a string literal, which gives it the type flags dot string literal, which happens to be string-like. So we do this check where if the source flags are string-like and the target is string exactly, then you know that they are assignable. You can just check that sort of what category they're in and quickly return true. And since the flags are set when you're doing checking early on, then it happens quite fast because you're just checking some numbers. And this also applies to number literals. So if this was a number literal and this was a number, then you could quickly find out that something was number-like is assignable to number, and so on. The next round of checks is related to, which is sort of the recursive worker for check type related to. It's where things recur over and over again for recursive types. But it starts off with some ad hoc checks. There's like a couple of fast paths. So if A is assignable to B, if A is assigned to B or undefined, and A doesn't have undefined in it, there's no point in checking undefined anymore. So there's a fast path that just checks the undefined, and that often makes B not be a union anymore, which makes things faster because you're not comparing a union to not a union. We also do excess property checks and common property checks there. So excess property checks disallow A, B being assigned to A. And I know in the previous video we actually looked at AB being assigned to A, and that's fine as long as AB is not fresh. And fresh here kind of basically means it was just written in an object literal. So if you're assigning something like var A equals the object literal AB, there's no way that B is ever going to get used because the thing you're assigning it to doesn't have a B property. And so there's no legal way to refer to that property. And so you probably just made a mistake and maybe your types are wrong or something. An even more insidious one is when you assign some random type to a weak type. A weak type is one where all of your properties are optional. So if you have A optional, B optional, you can assign C to that. And structurally that's fine because There's no A, fine. There's no B, fine. And there's C. C is extra. It's fine, right? Except that makes no sense. And it's even worse is that if this is some long name, this could be a typo of that long name, and now we have no checking on like options bags and things. So common property checks, while again are not really structural, they're disallowing something that should be allowed in a structural system. They're also disallowing a thing that is almost certainly a bug. And those two checks need to see the whole type before we start breaking down intersections or unions or things. All right, but before we start breaking things down, there's something called recursive type related to, and that does caching and what Anders calls turtles all the way down detection. So it's basically preventing infinite recursion. So if you're checking something like this interface, we have interface node of t, and then the first property has a type node of t. A naive structural check is going to look, say, try to answer is node of AB assignable to node of A. Well, the first thing it's going to do is say, well, I need to find out if the parent is assignable to the parent. Is node AB assignable to node A? Well, let's look at the node. And then the first property of that is node AB assignable to node A? And this will continue forever if you let it. So recursive type related to tracks source target pairs and make sure they don't appear more than 5 times on the stack. And just keeps a stack of types that are being compared. And along the way, it caches them as well, because you have these pairs and you're tracking them. Once you get an answer back, you can just record the answer. So if the result happens to be true, then you can just quickly return true the next time you ask this question, which of course in a real program helps a lot, because this sort of thing will probably happen a whole bunch in the program. Interesting note is that when it hits the turtle cutoff, it actually doesn't return true or false. It returns maybe. So this function actually returns a ternary. And maybe sort of means skip, actually. We probably should have called it skip, because it just skips to the next property. And if that one also recurs infinitely, which this one will, it'll skip to the next property. And then if it gets an answer there, then that's what gets used. But we never go back and check these two. They're just assumed that this is true, then these were probably also true. And interestingly, if all of them are maybe, then the caller recursive type related to flattens that out to false, because it doesn't, I think the idea is that it doesn't seem like they're assignable. So this doesn't actually check any types per se, but it does a lot of caching and things to make structural checking actually work in practice. So structured type related to is a big bag of code that checks all of these structured types that are left of Typescript, which is sort of just most of them actually. You have unions and intersections, you have some variance probing for later for objects and conditional types. You check type parameters, you check key of types, you check indexed access types, you check map types, you check conditional types, you check template literal types. Those are the ones that have backticks and, $. You check string mappings that you can uppercase it to string type and so on. You check substitution types, which have special rules, even though they're just type parameters that happen to be inside the true branch of a conditional. Under certain conditions, it gets complicated. There's a faster path for instantiated generic types. So if you have, say, something like array of A being assignable to array of B, if variance probing nailed down exactly how A is, or how the type parameter of array is treated with respect to variance, then you can say, well, we don't have to do all of the check here. We can just check whether A is assignable to B, much faster than checking whether array of A is assignable to array of B, unless the type parameter happened to be contravariant, in which case you'd have to check whether B was assignable to A. So again, variance is sort of complicated. And finally, tuples. So that's just a giant bag of code. Not a bag. It's a giant piece of code that has all the rules for assigning these individual things. And then at the very end of structure type related to are object types, which unlike micro TypeScript combine properties and call signatures, because that's what JavaScript actually does. It's kind of easier for me to think of it as objects having properties and functions having signatures, but in reality, JavaScript says, well, functions and objects are the same thing. They can have properties, those need to be assignable. They can have call signatures, those need to be assignable. They can also have construct signatures. That's like new, calling something with new. That needs to be assignable, and also index signatures. So that's these index signatures are the things that say something, any property that's not defined in this list has to have this type. And they have their own somewhat wonky assignability rules as well. And that actually is the end of assignability in real TypeScript.